of Advent of Code. The puzzle should unlock in about a minute, so I'm looking forward to getting started with it. Without further ado, let's make sure my setup is correct. Let's see. Input stay 08 input. Let's copy the template around. Oops. Right, bad. Okay. And that is now day 08. Cool. So we'll see what the challenge is in about a minute. And hopefully the stream is stable. If there is a problem, hopefully I'll discover it pretty quickly. This is a new location for me, so who knows what's going to happen, but it's at least the same computer as the past couple of days with less MacGyvering, I'll say. Definitely a lot less MacGyvering. Also, I tend to have to clear my throat a lot after I eat, and I just finished eating a burrito, so, you know, that's why I'm clearing my throat a bunch. Alright, puzzle in lock in about 20 seconds. So let's find out what we have today. Five, four, three, two, one, and let's go. We have a sleigh. We need the license key. Produce a tree, right, I do. Okay, metadata, and yep, makes sense. Add up all the metadata entries. Okay, fair enough. That's, that looks easy enough. This is just mostly a parsing job. Whoa! What's this? Oh. This example, which is marked with, A has 3 metadata entries, 1, 1, and 2, right? All of the metadata entries. Surely this isn't asking me to just add up all of these numbers. So where's the other piece of this? Oh, a node is a header, the number of child nodes, the number of metadata entries, and then the child nodes come first, and the metadata entries. Got it. So this is going to be a set of numbers that I'm going to need to parse. Got it. Great. Okay. So let's paste this in and save it. And we only need to read one line, so that's easy enough. Trees is going to be strings dot split L with space, and then for range entries, we need stir column, and we're going to need strings. Okay. It's going to be conv dot a to I of n, and then values of I is going to be okay. That just needs to run once, so that's okay. Fine. Something like that. Okay. make an int with length of entries. Okay, so let's do that for now, just to make sure that we parsed correctly. Values. Great. Yep, that looks fine. Okay, so now we need to set up the parser. So we need to define what a node is. So type node struct is going to be a recursive data type, which funnily enough looks a lot like a interview question I like to ask. So let's see. So we have the number of child nodes, which is just going to be allocated as part of the, so children is going to be a list of nodes, and then we're going to have some metadata entries, which are potentially just going to be some numbers. So let's see this. Yep. So I think that should be fine. Okay. Great. So now for so we have a current cursor location, and we have the current value at that location. So I'm going to do this by hand. I'm going to guess that there's going to be a bunch of skipping around. So cursor is going to be starting at location 0, and then we'll move around. So first we're going to assume we start at the beginning of an entry. So I'm going to start by saying child count is going to be values cursor plus metadata count is going to also be values cursor now. Okay, now let's see. I am glitching a lot on Indian network. Twitch shows my stream is stable, so I think the problem is on your end, sorry. So I don't know what's going on. It seems to be fine according to Twitch, sorry. You're just gonna have to cope with it. I think the worst case, the YouTube video should be in full resolution. Okay, now we're going to need to allocate the node. So we're going to make a new node that has a node list that has length child count. And then has a int list that all has length metadata count. Something like that should do the trick. Okay. Now we need to then parent is going to be nil. Okay. So let's see. Now what do we do? We also need the running total is going to start at 0. Okay. So now we're going to need to essentially break out of this. Yeah, it seems reasonable. Okay. How do we do this? We're also going to keep track of the number of sibling nodes. Okay. Great. So now we finished parsing the header. So now we proceed to the next node. Okay. Our current node. Current node equals. Okay, something like that. Ampersand, where's my ampersand hiding? Sorry, unfamiliar keyword, there we go. Okay. Great. So now we can turn over control. So if parent is not equal to nil, okay. Actually, I don't think I need that after all. So if parent is not equal to nil, then we need to set parent dot children siblings equals current node, and then we need to set siblings plus equals 1. Okay, that seems reasonable. Yeah, I'm sorry I can't make this downscale. I wish Twitch dynamically offered re-encoding, but they don't for some reason, so sorry. Okay, let's see. Now, okay, if siblings so sibling count is equal to parent.length, or length of parent.children, minus 1. Yes, that's correct. So if we have all of the siblings, then we need to return control to the parent, because parent dot okay, I is 0, I is less than length of parent dot metadata, I plus standard loop, standard business. Then we're going to do cursor plus equals 1. Actually, we'll do that. Yeah, that seems fine. Okay. Cursor plus equals 1, and then values at cursor, parent.metadata equals values.cursor. The other situation is what happens if we are at a root node or not a root node, a leaf node, and there are no more children. If there are no more children, okay. So now we need to handle the leaf node case. Handle leaf node case. If child count is not equal to 0, then, and then after this we need to make parent, oh, that's the other aspect. Actually, that needs to be recorded here. I'll maintain this as a doubly linked structure. I think that makes my life easier rather than remembering where in the tree I am. Yeah, that's fine. I can afford the memory usage. Okay, so something like that should do the trick. Okay, great. Now let's see. Parent. Think about this. Okay, so if we're at a leaf node, then we just immediately proceed to current node metadata. We essentially need something like this. And then, furthermore, we need to say, do this, running total metadata is what I called that. I'll use that cursor. Okay. Great. That and that should do the trick. So now we keep on running. Cursor is not equal to length of value. That is rough. Let's run it on the basic input first. DOH simple. So let's paste that in there. Make sure that looks reasonable. Okay. No pointer reference. If parent, right. Okay, great. So we've handled the leaf node. We've handled the case of what to do if all of your siblings are accounted for, which is to pass control to the parent node. Okay, and if that's the case, then we also need to, after that's done, set parent equals current equals parent dot parent. I think that should do the right thing. Okay, let's see what happens. Okay, that ran to completion. Let's see whether that generates the correct result. Result equals running total metadata. So let's see what happens. The sum is not 26, it needs to be 138. So let's print the tree and find out what I did wrong with the tree. Okay, so let's just let's print out the first node, which is going to be root equals right. Okay. Okay. Okay, so let's make sure that that looks reasonable. This root node has no parent. It needs to have some children. So, length of root dot children. So let's make sure that value is even correct, because if that's not correct, then we have a serious problem. Okay, root node has one child. Why does root node have... Yeah, root node should have two children, so what's wrong with that? Child count should be the... Let's just make sure that's even correct, because if that's not correct, we're doing things wrong. Okay, yep. 2, 0, 1, 0, and I don't know why 2, 1, 1 showed up at the end, because, yeah, let's see, what is that? Oh, 2, 1, 1, and 2 are the metadata entries? No. Oh, the 2 is C's metadata entry. Okay. Let's just comment that out for a second. Let's look at this. Okay. Okay. Great. Let's try that. 2, 0, 1, 0, but then 2 and 1 get spuriously spit out. Oh, because after D finishes, oh, I see. We need to parse my metadata first. Okay, now let's try that. Right, because if I have no children, I need to parse my metadata first, because no child will come to do it for me. Oh, and we never set the sibling count to back to 0. That's why. Okay. So when do we set the sibling count back to 0? There, like that. Okay. No, it's still wrong. What's wrong with that? Hello, Alexandria. How are you? Okay. So let's see. Let's try that. Okay. Starting new node with the children and the metadata. Child count, metadata. Okay. Starting node with 2 children and 3 metadata. Starting node with 0 children and 3 metadata. Starting child with 1 children and 1 metadata. Starting child with 0 children and 1 metadata. And then, for some reason, it repeats. And that ought not to happen. So we should always start the top of the loop. Gee, thanks. Way to make me feel bad. This was a nice, easy one. Well, you know, we're only 24 minutes in. I consider it an easy one if I'm done in an hour. Because I am also streaming and explaining as I go, which takes energy. Okay. So, we need to clean up after our children. Change that we increment the cursor. Increment the cursor, read the current value. Do we need to increment the cursor again after the last value? Yeah, okay, I think that's my problem. Let's think about it. Okay, I think I do need to do that after that. Oh, am I also skipping? I think I'm skipping. Yep, okay, that needs to go there. That's my first bug. My second bug is, so this has the same problem here. Does that solve that? Let's try that. 132, that's slightly different than 138, that's getting closer. Okay, 2 children, 3 metadata, 0 children, 3 metadata, 1 child, 1 metadata, 0 children, 1 metadata, and then for some reason it's not parsing the last yeah. Okay. Root node is Okay. If I reach the end of this, okay. Oh, I see. Let's try this. Cursor is at position D. Let's just check that. Wait, this is day 8, not day 7. How can you possibly have slept on it by now? This doesn't make any sense. I don't understand why you're saying that. Okay. Oops. Print F, not print line. Okay. Cursor's at position 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so that is 0 children, 1 metadata. 9, 10, 11, 12. Oh. Right. Right. I need to recursively clean up the parents. Okay. Parent is not nil. Okay. Right. We put that in there, and then now for now we need to clean this up. For a parent, it's not nil. I think that will do the trick. Siblings plus equals 1, sibling equals 0. Okay. Right. Let's see that. Okay. No, that's fine there. The trick comes here. Okay. Yep. Okay. Right. I think something like that. Let's see. Okay. Oh, indented too far. Okay. That's okay. Great. As long as parent is not nil, I'm going to keep popping up the tree. Okay, I think that should do it. Oh, I see. Right. We need to count how many siblings have been populated so far. Sibling count is going to be 0. 4i is equals 0 is less than length of parent.children. Actually, for range parent.children, if v is not equal to nil, sibling count is going to be okay. Right. Okay. I think something like that should do the trick. There's probably a less spaghetti way of doing this too, isn't there? Yeah, someone was likening listening to me code to like pair programming with someone having it on as background noise. I wonder how my partner who is studying for a coding exam feels about that. Let's see. Okay. So we need to evaluate this. Okay. This is actually fine. String count is 0. Sibling count is equal to length of that. Then we do, no, that was fine. So sibling count is not equal to that, then we know we need to do another cycle. We need to break out of this loop. Okay. Otherwise, we populate our parent, and then we set the parent to parent's parent. And we set, at some point here, we need to set siblings to 0. If we have I see. Okay. Can't rely on siblings as a running variable. I have to count the number of siblings instead. Right, okay. to happen. Let's see, if there are no siblings, we want to write to the first position. If there's one sibling, we want to position 1. Yep, that's fine. Okay. After we do that, we need to re-evaluate that. Yep, that looks fine now. Okay, let's run that. Almost. So is that position 12? Huh. Okay. Let's see. I think that will work. That seems fine. Yeah, I don't know why that's broken. Okay, that looks okay. Okay, that seems fine. Why does that not work? We never pop up a layer. Why do we never pop up a layer? And also, why do we never say that we're done with siblings? We definitely should be running at least one of these. Oh, because we never set parent to anything else. Okay. Parent is equal to parent.parent. That looks fine, actually. So the first time it runs, parent is not equal to nil. The next time that we recurse, oh, I see. Okay, that's the problem. We need to set parent to ourselves. If we have at least one child, that's going to immediately follow us. So parent equals current node. Okay, let's try that. Index out of range at line 74. Someone should do mechanical keyboard ASMR, but that person is not going to be me. Let's see. So our parent is not nil. Then why is sibling count off? And have it should work. Okay, so let's see this. Start position 2, starting node with 2 children and 3 metadata. That looks okay. Populating parent's child number 0. Not yet done with siblings because there should be one more sibling. Yep. Versus position 2, starting node with 0 children and 3 metadata. That looks fine. And we populate Wait. Why am I populating? Oh. Oh. Whoops. I have a settle off by 1 error. In fact, parent will never be nil now, so we can actually just do this. Okay, that looks fine now. Oh. I see. This needs to run under here. This is always going to be my parent node parent.children. Yep. Okay. Seems fine now. So if current node parent is not equal to nil, then we need to do that. Yep, okay, that's fine. And now I see, if we ever get to a leaf or otherwise, yep, if we ever get to a leaf, yeah, I don't know, you'll have to figure that out, Alexandria. Okay. My current I don't actually, so that's wrong. I don't actually need that. Yeah, in fact, I don't actually need that. I don't even think I need that. Let me think about that. No, I do need parent. Okay. Let's think about how we do this. So we just use that to populate current node. That's fine. Okay. That's okay. That's okay. Looks okay. Looks okay. Now we can change this to current node. Current node equals current node parent. Okay, that's fine. Does that work? Okay. Try that. See how that goes. Lines 94 and 99 are wrong. This is all wrong. Probably overcomplicated this actually now that I think about it. 94, 99. What have I done wrong? Unexpected else. Oh, I see. Right. if I have no parent, parent is nil, then equals. Okay. Okay. Continue. Okay. So now we definitely know that we are not at the root node. Okay. If we're not at the root node, then we need to populate our parents. Yep. And then while the current node's parent is not null, we are going to do that because we're leaving parent alone. And then after this loop is done, we have to make current nodes confused by this. Okay. So if we're not yet done with siblings, then we still have the same parent. Otherwise, we pop up a level, and we need to set parent equals current. Okay. I think something like that should do it. Getting closer. Or farther, actually, I think. This is really annoying. I've messed something up in here. I know I've messed something up in here. Okay, let's see. Parent starts as nil, that's fine, that's appropriate. Then we move on to the next node if, oh, righto. Okay. Okay. Great. Okay, that's fine. Okay, that's okay. Yep. Child count is, yep. That looks okay. Okay. No, that's okay there. That needs to execute regardless. I'll do this. This is spaghetti. If we have any children, and at that point we set that, we have any children, okay, if we have any children, then we need to make sure to set that and then continue. Yeah, because we'll resolve those recursively later. Okay. Nope, actually we don't get to do that either. Why do I feel like I'm doing something wrong? What happens if I run this? Ooh, 75 is wrong. Okay, right. If current I think I need to do that, and then that works. Okay. Now what's wrong? Line 85 is wrong. Do it. Now 85 is wrong. Cursor is at position 9. Cursor is at position 9. That's here. 0 children, 1 metadata. Populating parents, child number 0. Why do we think that we're not done with our siblings? We should be done with our siblings. Okay. Oh. There. That should do it. Popping up a level. Now we're cycling at line 100. Right. Okay, now I understand why we need to do that. Okay, right, that makes sense. Okay, so now we run this here. Now that is correct, so I think we're okay. Sum is 133, but not 138. Okay. Number of root children is 0. That's fine. Up a level. Helping parents' child number. Okay. Cursor is at position 0. Cursor, 2 children, 3 metadata, 0 children, 3 metadata. That's fine. One child, 1 metadata. Wait. Okay. Position 0. And then position 2. 5, 6, 7. Position 7. Position 7. One child, 1 metadata. Oh, but we can't pop up a level because we haven't done all of our children. We still have children that need to run. Okay. Right. And that's if I have any children, then I need to continue. Yep. I think that's right. So that's actually fine. Okay. Try that. 9. From data, popping parents are 0, popping up a level. Not yet done with. I should be done with all of my siblings at that point. Why am I not done with all of my siblings? That should be done with all the siblings. Okay. So find out what's going on there. Okay. Position 9. Populating parent's child number 0. Yep, that's fine. So that's going to be C's child D. Popping up a level now to finish up C. So C, for some reason, thinks that it has 1 child populated, but it expects to have 2 children. But C, we originally said, is supposed to have 1 child. So that is our problem. Sibling count is set to 0. Okay. This is very fascinating. What have I done wrong? Okay, populate that. We have done that correctly. That's very strange. Because we iterate again. Current nodes, parents, children. Yeah, I don't know what's going on with that. Populating parents, child number 0. Then we... Oh. No, because child count is 0. I have no children, so I can pass here. I have, yep, that passes there. Count my number of siblings. Populate that. That seems fine. Okay. Debugging. As long as I haven't hit the top of the tree. Calculate my siblings again. That seems fine. Let me just double check this. Yeah, I'm only going up a layer if I think I can. Populate the metadata first, that's correct. And then that's okay. Okay, I just need to give every single thing like a unique identifier or something. Yeah, I don't know why it expects there to be 2 children, like, because it sounds like we popped up too many layers, but we know we popped up only 1 layer. So we have shows. Yeah, I don't know what's going on here, and it's intensely frustrating. Uh-oh. Am I having stream rate issues? Let me just double check whether OBS is having trouble. Yep, OBS is having trouble. I'm seeing bandwidth contention. Sorry about that. That's unfortunate, but nothing I can do about it right now. Okay. Okay, let's try this. Oh. I see. When I pop up from D to C, it is indeed the case that it expects there to be two siblings. Okay, that is actually correct. So it means that either B or C is not saving. Well, B is a leaf node. Let's just print the root node. Really curious what the root node's value is. Okay. Root node. Ooh. Oh. Ah. That needs to happen. That needs to happen here. Okay, we ran this at the wrong place. Okay. Now that should be correct. Okay, that's closer. If I have more children, I need to continue. Okay, that should definitely run now. Sibling has 0. Current nodes. Parent is nil. Oh. What? Okay. Okay. Why is this not right? If I have no children, pop it in the metadata, that's fine. Now. This should always run. Why does this not run? Probably because parent is never being updated. Oh. Oh. Sigh. Right. I hate copy pasting code. Okay, that should do it. There. Yay! Okay, now that matches the simple input. Now let's remove the diagnostic print. Okay, that looks fine now. Now let's run it on the full input and hopefully that should work. Let's try that. Correct. Great. That was way too much debugging. Okay, part 2. Find the value of the root node. If node has no child node, its value is the sum of the metadata entry. Okay. Great, that's fine. So now we need to compute as we go along. Okay, something like that. That's fine. I can do this all with one set of code. If I wind up populating the metadata, then the value is the node, current node. Okay. Current node dot value is plus equals. Okay. Now great. I think that's the only other place that happens. Don't need the root children either. Part A result is that. Okay, that seems to be pretty easy. Root dot value. Okay, great. Yep, so that's fine. That's fine. And now here. So if we've popped up a level, we've completed all of our children, so that's easy enough. Index is that index is not equal to 0, and index is less than or equal to length of current node parent dot. Yeah, that seems fine. Actually, wouldn't this be more convenient if I did this? I think it would be. Great. Good, it'll still work. Okay. Then current node dot equals current node dot children sub index minus 1 dot value. Yep. 66. Yep, that looks fine. Great. Shove that in there, and it's correct. And that means that we have finished day 1 in, or day 8 in 1 hour 8 minutes. I'm just going to clean up a bunch of my print statements. That's fine. I know where that is. I'm going to leave that alone. I'm going to leave that alone. Do that. Do that. Okay. I think that that seems reasonable. The other cleanup I want to do is, I just finished part 2. The other thing I want to do is I wonder if I can get rid of the spurious parent variable. What am I using parent for? Oh. I'm just using parent here because I need to keep track of if I'm creating a new sibling. Yeah. You know what? That's good enough. I'm happy enough with that. Let's just make sure that works. Yeah, that's clean. That's clean. I'm just going to use hide that behind a verbose flag. Flag, bool, verbose, false, print, verbose, debugging, output. Okay. F. That's fine. If verbose, and do that. So now this should run cleanly. Yep, that should run cleanly, but yeah, looks good. Okay, great. Daylight go, add daylight go, git submit day 0880 solution, git push. Okay, that is the stream for today. See you all tomorrow.